Explain the following physical properties. We are going to focus on boiling points of alkanes based on molecular weight, isomeric alkanes and cycloalkanes. For this example, I'm going to focus especially on isomeric alkanes and cycloalkanes. Now let's look at what we have here. Okay, arrange the following compounds in order of increasing boiling points. Explain your answers. Okay, first of all, let's determine how many carbon do we have. Okay, so we have 5 carbon. Okay, the second compound is the same. We also have 5 carbon. The third compound is the same. We have 5 carbon. And then the last compound, cyclopentane, also 5 carbon. Okay, so from here, we know one thing for sure, that is they have the similar molecular weight or molar or similar mass. Okay, so when we have similar mass, okay, means that when we have similar mass, we are going to compare isomers first. Okay, so for example, you can see here, this one is linear, 5 carbon linear, 5 carbon, 5 carbon, but 1 branch. Here we have 2 branch. Okay. However, cyclic is not isomers, okay, because the formula compound is different. This one is just C5H10. This one would be C5H12. Okay. Now, so when we want to explain, we start to explain one by one. Find out the common thing first. That is the similar molecular weight. Okay, then explain one by one. What is the difference? Okay, for example, cyclopentane is cyclic compound. Pentane is linear chain alkane. Then 2-methylbutane has 1 branch, and 2,2-dimethyl methyl has 2 branches. Okay, so this is how you differentiate them. Okay, then next one, only then you explain why is it has the highest boiling point. Okay, for example, cyclopentane has the highest boiling point because it is a cyclic compound which has the biggest contact surface area and strongest van der Waals between molecules compared to linear and branch alkane. Okay, if pentane, because it is linear chain alkane. So when we compare pentane, we compare with the branch. So linear chain alkane has bigger contact surface area and stronger van der Waals forces compared to branch alkane. Okay, then only we go to the last one. Which one has the smallest, the lowest boiling point? That is 2,2-dimethyl propane because it has more branch. So when the number of branch increase, we have smaller contact surface area, weaker van der Waals forces between molecules. Thus, 2,2-dimethyl propane has the lowest boiling point. Okay, if let's say I put in another one, for example, I add in C7H16. So which one will have the highest boiling point? It will be C7H16. Why? Because the molecular weight is the highest. Okay, we always look at the molecular weight first. If it's only hydrocarbon, we look at the molecular weight. When it is molecular weight is the highest, then we compare molecular weight. If the molecular weight is the same, then we compare in terms of contact surface area. Okay, if we have the same number of carbon, then we will compare between cyclic and linear. So that's all for this part.